Hello everyone. Today we are going to start lecture 04 of class 8 mathematics chapter number 3, which is understanding quadrilaterals. In this lecture we are going to talk about various kinds of quadrilaterals which are present in our courses. There are total 7 types of quadrilaterals which we have to study, in which the first one is trapezium. Now you must have seen this figure many times, but you must be wondering what is its name. Well, it is called trapezium. Since it is a quadrilateral, it has 4 sides. And what is the property on the basis of which we are calling it trapezium, right? So what is trapezium? A quadrilateral having exactly one pair of parallel sides is called a trapezium. So what is a trapezium? A trapezium is nothing but a quadrilateral in which only one pair of sides, one pair of opposite sides. Okay, so AB and CD, you can clearly see the sides AB and CD are opposite sides and they are parallel. Obviously adjacent sides can't be parallel, right? So this is talking about the opposite sides. So we have this one pair of opposite sides as parallel, which is AB and CD. So we can write in ABCD, AB is parallel to CD, which implies that quadrilateral ABCD is a trapezium, right? So this is the first quadrilateral which we have to study, which is trapezium. Okay, now what about the non-parallel sides? These are the sides which are called non-parallel sides, and clearly they are not parallel, right? They may also have some properties, that is, they can be equal in length. They can't be parallel, but they can be equal in length. If that is the case, then we got the second quadrilateral, which is called isosceles trapezium. Now what is the isosceles trapezium? It is a regular trapezium. Only difference is now these non-parallel sides are also equal, right? So we can write a trapezium is said to be an isosceles trapezium. A trapezium is said to be an isosceles trapezium if its non-parallel sides are equal, right? So in this case, what are the non-parallel sides? In this case, we had AD is equals to BC. Thus we can say if ABCD is an isosceles, that is, if ABCD is an isosceles trapezium, then AB is parallel to CD, which is clear. AB is parallel to CD, and since it is isosceles, we have AD equals to BC. So we have AD equals to BC, that is, the non-parallel sides are equal. So that is the only difference between a simple trapezium and a isosceles trapezium. Also, in an isosceles trapezium, there is one more property. In this isosceles trapezium, these opposite angles on the base and opposite angles of the top are also equal. That is, angle A is equals to angle B and angle C is equals to angle D. So this is kind of a property of an isosceles trapezium, and you can easily verify it. If you want, then you can draw perpendiculars like this. Okay, Now you can clearly see these perpendiculars, let's suppose P and Q, the height are same. These AD and BC, we have made it equal, and since they are perpendicular, 90 degree are same, so you can make these two triangles congruent. Now what does congruent triangle means? Congruent triangle means that the two triangles are equal in lengths, all the three sides are equal and all the three angles are equal. Then also you can prove that angle A equals to angle B, right? So in this way you can prove that these angles are equal. So in an isosceles trapezium, we have opposite sides are parallel and the non-parallel sides are equal, right? So this was all about isosceles trapezium. Now let us talk about another quadrilateral which is very, very important, and it is parallelogram. Now what it is very important? Because a parallelogram is a fundamental quadrilateral which gives birth to three more quadrilaterals of its family, which are rhombus, square and rectangle. So parallelogram is a parent figure of all these three quadrilaterals. Now what is a parallelogram? What is the definition of a basic parallelogram? So definition is a quadrilateral is a parallelogram if its both pairs of opposite sides are parallel, right? So a quadrilateral is a parallelogram if its both pairs of opposite sides are parallel. Okay, so in this quadrilateral we can clearly see the pair of opposite sides, that is AB and CD and AD and BC are parallel. So we can write that if this quadrilateral ABCD is a parallelogram, then AB is parallel to DC and AD is parallel to BC. So you can clearly see that these two sides which are opposite are parallel, and these two sides AB and CD which are again opposite are also parallel. I will tell you this in the properties of parallelogram, that these sides are opposite. These sides are opposite and parallel, so they are equal to. I'll tell you this in the properties of parallelogram, but you can clearly see that if the opposite sides are parallel, then clearly AD is not only parallel to BC, but it is also equal to BC. Similarly, AB is not only parallel to DC, but it is also equal to DC in length also, right? So this is a parallelogram. So these are just the definitions which are needed to call a quadrilateral a particular name, right? So like in trapezium, we call that if one opposite sides or one pair of opposite sides is parallel, we can call it trapezium. Similarly, to call a figure an isosceles trapezium, we just have to prove that one pair of sides is parallel, that is, it is a trapezium, and then we have to prove that non-parallel sides are equal. Similarly, to call a figure parallelogram, we just have to verify that both the pairs of opposite sides should be parallel. So this is something called parallelogram. Since the sides are parallel, hence the name parallelogram, right? So let us talk about the next figure, which is just like the son of parallelogram, and it is rhombus. Okay, rhombus is exactly the parallelogram. The only difference is in parallelogram opposite sides were equal, in rhombus all the sides are equal, right? So that is the only difference. So since it is a parallelogram, we can define it in terms of parallelogram as rhombus is a parallelogram having all sides equal. Okay, or you can say a parallelogram having all sides equal is called a rhombus, right? So it is the parallelogram, and the only difference is all of the sides are equal. So if ABCD is a parallelogram or rhombus, we can say if ABCD is a rhombus, then the first condition would be AB should be parallel to DC since it is a parallelogram. Second condition should be BC should be parallel to AD. So opposite sides are parallel. These conditions follow from the fact that rhombus is also a parallelogram. And the third and important condition which separates rhombus from a parallelogram is all the sides are equal. That is AB is equals to BC is equals to CD is equals to AD. So this is all about rhombus. So what is a rhombus? It is a quadrilateral which is a parallelogram, and then a parallelogram having equal number of equal sides. That is, the side lengths are equal, right? So ABCD is a rhombus. You can clearly see that in a rhombus all four sides are equal. So again, whose parent figure it is? Rhombus can be the parent figure of a square. Similarly, in parallelogram we had opposite sides equal. So parallelogram is a parent figure of rectangle. Okay. So a specific case of parallelogram is what we call rhombus. Similarly, a specific case of rhombus when internal angle becomes 90 degree would be a square. So let us talk about first the rectangle. Now what is rectangle? You can clearly see it is a parallelogram. It looks like a parallelogram. The only difference is each interior angle has become 90 degree. This L is a symbol for 90 degree, right? So it is just a parallelogram whose opposite sides are also equal and parallel, but the only difference is that each interior angle is 90 degree, right? So we would treat rectangle as a parallelogram. So we can write the definition of rectangle as a parallelogram whose each angle is a parallelogram whose each angle is a right angle is called a rectangle, right? So a parallelogram whose each angle is a right angle is called a rectangle. So in this rectangle what we have all interior angles to be 90 degree. Now since it is a parallelogram, so the property should apply on it. So if ABCD is a rectangle, then now the first thing a rectangle is, it is a parallelogram. So firstly we would have the same condition. AB should be parallel to CD. Again, since it is a parallelogram, one more pair of sides is parallel, that is AD is parallel to BC. Now the condition comes, since it is a parallelogram, so these conditions would follow. Now what is different in rectangle and parallelogram? Interior angles. So in this we have angle A is equals to angle B is equals to angle C is equals to angle D, which is nothing but 90 degree. Okay, so this was all about rectangle. So what is a rectangle again? A rectangle is a parallelogram whose each interior angle is equals to 90 degree, right? Now you can clearly see this is a specific case of parallelogram itself. Now in case of rhombus we saw that all four sides were equal. So if the interior angle becomes 90 degree, then it would become a square. Okay, so let us talk about square now. Now what is a square? You can clearly represent square with the help of three figures. First of all, square is a parallelogram whose all the sides are equal and each angle is 90 degree. Okay. Square is a rhombus whose each angle is 90 degree since sides are already equal. Or you can call a square as a rectangle whose all the sides are equal, because in a rectangle all the sides are already 90 degree. So let us define square in terms of rectangle, right? So we can say A square is a rectangle. A square is a rectangle with a pair. A square is a rectangle with a pair of equal adjacent sides. Right. So a square is a rectangle with a pair of equal adjacent sides. Okay. So what it means is a rectangle already has all the angles as 90 degree, which is the prerequisite for a square. Now what we are doing, we are just making sure that all the sides, not only the opposite ones, but even the adjacent sides of a rectangle are equal, and then it would become a square. Okay. So what we can tell is, if ABCD is a square, that is, if this figure is a square, comma, then what should happen? Then, since a square is a rectangle and a rectangle is a parallelogram, so AB must be parallel to, so AB must be parallel to DC. Second, AD must be parallel to BC. So AB must be parallel to DC, AD must be parallel to DC. Okay, these two pair of sides should be parallel. So this is because square is a rectangle and rectangle is a parallelogram. Now this is the condition of parallelogram. It is finished. Now square was rectangle. So the third condition would follow from rectangle. These two conditions followed from the fact that square is a rectangle, rectangle is a parallelogram. So we have to follow parallelogram. Now the second condition is that square is a rectangle, so the condition of rectangle should also be there. That is, angle A should be equals to angle B, should be equals to angle C, and it should be equals to finally angle D, which are all nothing but 90 degree. Now, so we have fulfilled the condition of parallelogram. After adding two conditions, we have become a parallelogram. Okay, let me talk from the starting. It would be easier. Let me write another condition also, so that I can show you what it means to study quadrilateral in a particular order. I've chosen to show you these things in a particular order with a purpose, and I'll tell you what the purpose is. Let me write the last condition for a square. That is, AB equals to BC equals to CD equals to AD. That is, all four sides are equal. Now let me talk about the condition. See, if you have given me a quadrilateral ABCD, or I have given you a quadrilateral ABCD, and I say only the first thing, that only AB is parallel to DC, that only one pair of sides is parallel, what you will say? You will say, sir, it is a trapezium, because only one pair of sides is parallel, and that is a requisite for a trapezium. Okay. Now if I add another layer to it and say that, okay, right, second condition, that another pair of sides is also parallel. Now what you have become? Now that quadrilateral ABCD, firstly you called it a trapezium, then you called it a parallelogram, because both conditions are satisfying. Now if I add another layer to it and say that all the four angles have become 90 degree. Now firstly it was trapezium, then it became parallelogram. Now after applying third condition, it has become rectangle. Right. Now if I add another layer to it and say that all the four sides of the quadrilateral are also equal, that is, they are not only 90 degree, the angles, the sides are also equal. Now after applying four conditions, it has become a square. Okay, so you can obviously recall the quadrilaterals with the help of these properties, and the order should be the same. That is, first, when only one pair of sides are parallel, it is trapezium. When both the pair of sides are parallel, it is parallelogram. When all the angles are 90 degree, it is rectangle. Okay, when all the sides are equal, it is square. Right. So this was all about how we construct a square. Now let us talk about the last quadrilateral, which is a kite. Okay, so what do we mean by a kite? Okay, so you can clearly see it is a very cute quadrilateral, right? And we have already flown kites on some occasions, some special occasions, and you have seen that kite exactly looks like this. So what is a kite and what are its properties? Okay, why are we interested in a kite? So kite does not resemble with any kind of parallelogram, so it is not from the parallelogram family. and also there is nothing to be parallel, so it is not from the trapezium family again. So we will not write the definition of kite in terms of trapezium or parallelograms. We will simply call it a quadrilateral. So a quadrilateral is a kite comma, if it has two pairs of equal adjacent sides and unequal opposite sides. So that is the definition of kite, which simply says that a quadrilateral is called a kite if it has two pairs of equal adjacent sides. Let me see. The one pair is AB and AD, obviously they are equal in length, and the another pair is BC and CD. Okay, so this condition is satisfied that two pairs of adjacent sides should be equal. AB and AD are adjacent. Similarly, BC and CD are adjacent. And it also says that there should be two pairs of unequal opposite sides. Now AD and BC are opposite to each other, and obviously they are unequal. Similarly, another pair AB and DC are also parallel to each other, but they are also unequal. Right? They are not parallel, right? AB and DC are opposite. They are not parallel. Okay. AB and CD are opposite also, but again they are not equal. So they are also one pair of sides which are opposite but not equal. Right? So the kite simply states that it should have two pairs of equal adjacent sides. So if this figure ABCD is a kite, then it follows that first AB is equals to AD, right? Second condition, because they are the equal adjacent sides. Second condition, BC equals to CD, that is the another pair of adjacent sides which are equal. BC equals to CD. Third condition, what is the third condition is that AD is not equals to BC. AD is not equals to BC because they are forming a pair of opposite sides which are unequal, as the definition says. And similarly, the fourth side AB is not equals to CD. Again, AB and CD are opposite sides in a kite and they are unequal. So a quadrilateral ABCD is called a kite if two pairs of adjacent sides are equal and two pairs of adjacent sides are unequal. Okay, two pair of adjacent sides are unequal. Clearly you can see AB and BC are also adjacent sides. Okay, it is written in the form of opposite, but we can call it in adjacent also. You can see that AB and BC are also adjacent sides. So this pair of adjacent sides is not equal. Similarly, AD and DC are also adjacent sides. Similarly, this pair of adjacent sides is also not equal. So this was all about the 7 quadrilaterals, okay, which we are going to study. In the coming lectures, we are going to talk about the different kinds of properties which these quadrilaterals hold, and we'll solve some questions. So this was all about this lecture. Thank you for watching this lecture till end. I'll see you in the next lecture. Till then, goodbye.